Hi, this is Sung and I'm your online maths mentor, and in the last couple of episodes we've been starting the topic of polynomials, and we've been looking at polynomials and we've been looking at how to divide one polynomial into another polynomial. But I want to look today in this episode at two important theorems, of which we're going to look at the first, right? So the two important theorems that we're going to be looking at when it comes to polynomials are the remainder theorem and the factor theorem. And this particular episode focuses on the remainder theorem. And this is how the remainder theorem works. And this is what the remainder theorem is. So if you have a polynomial, p of x, and you divide it by x minus a until the remainder does not contain any x terms, then the remainder is equal to p of, or the polynomial with a substituted in for x, right? And whatever the constant term that you get at the end will be, that will be your remainder, okay? So basically, what it means is you don't have to go through the process of dividing long division. You can just substitute your a term in, and that'll give you your remainder. Okay, let me demonstrate that with this particular question. What is the remainder when p of x, which is x squared plus 7x plus 15, is divided by x plus 3? Let's do it by long division first, and I'm going to go through this fairly quickly and fairly concisely, because I'm assuming that you've had the practice that you need. But let's do it by long division and compare our answer from long division with the answer that we get by using the remainder theorem. Okay, so let's work that out. Okay, so basically what you've got, x plus 3 into x squared plus 7x plus 15. All right, x plus 3 is going to x squared plus 7 x times. So we'll put x up the top. X times x is x squared. X times 3x is plus 3x. You minus, and that gives you 4x. Bring down the 15. And then you've got x plus 3 into 4x plus 15. The answer is 4. 4 into x plus 3 gives you 4x plus 12. You minus, you take away, and your answer is 3. So in other words, your p of x, which is your x squared plus 7x plus 15, is going to be equal to x plus 3 times your quotient, which is x plus 4, plus your remainder, which is 3. Now, the way the remainder theorem works, in this case, -3, if you substitute a for x, what does that divisor then become? The divisor then becomes 0. Does that make sense? Which means that if that becomes 0, 0 times whatever your quotient is, whatever your answer is going to make that 0. Does that make sense? So in other words, what's left over? If that whole thing is equal to 0, what's left over is your remainder. Does that make sense? So in other words, p of a will always equal your remainder. Does that make sense? Got it? Okay, so I'll show you how this works when we use the remainder theorem. So we're looking for a remainder of 3. Okay, in the end. So let's work this out. X plus 3 equals to 0. X would be equal to minus 3. Therefore, A would be equal to minus 3. The A that we're looking for is minus 3. Okay, so P of minus 3 equals to, so we substitute this into that equation, minus 3 squared plus 7 times minus 3 plus 15. Substitute that in. Minus 3 squared is 9. 7 times minus 3 is minus 21. Plus 15. 15 plus 9 is 24. Minus 21 is 3. So your remainder is 3, which is basically what we got in this question as well. So does that make sense how the remainder theorem works? Basically what you're doing is you're substituting whatever a is to make the binomial that you're dividing by equal to 0, and whatever your remainder is will always be the remainder of what you get when you divide the polynomial by the binomial divisor. Okay? Good. That's basically what the remainder theorem is. In the next episode, what I want to do is look at how to do the factor theorem, or how the factor theorem works, okay? And then we'll look at a couple of problems, okay, to do with both the remainder theorem and the factor theorem. Thank you very much for watching. Bye.